In this laboratory, we're going to be going over a simple pacemaker. This is for embedded systems and applications. So to prepare this, we're going to need to have our manual handy, which hopefully you'll have in the description below the like button. We're going to have switch 1, and we're going to connect it to our PF4. Consider this interface when justifying the need to set bit 4 in the PUR register during the initialization. So our starter project is going to be this, the Lab7. We have this downloaded, and this is downloaded from previous video. It's in the playlist below the like button. The purpose of this lab is to walk through the design process to build a very simple pacemaker. The system will read from a switch, so our input, make decisions, and outputs to an LED. We're going to learn and understand the steps required to initialize parallel ports. We will write subroutines that wait for the switch to be pressed, wait for the switch to be released, and then create an output pulsed of fixed duration. So again, we will make a subroutine. It's going to wait for our switch to be pressed. So it's just waiting for us to press the switch. Once we press the switch, it's going to wait for it to be released, and then it's going to create a output pulse of a fixed duration during that time. We have our system requirements here. We're going to just briefly go through this. We have a diagram for this. We have these instructions. We'll go over these again in the actual code, because that's what we're going to look at next. We have this logic analyzer here. This is important. We should keep this in mind because it's going to help us code for this. And then we have our starter project, but this will come back in the code. We also have some pre-lab reading. So we have this information right here, but we're going to go over all of this because it is also included in the code. So now let's actually go to the code. Inside of our code, we have some comments right here of what we're doing. So we're going to run on our TM4C123 launchpad. We're going to take input from a switch, and then we're going to output to a PF3, so a green LED is ready. We're also going to output to our PF1. It's a red LED, a ventricle trigger, so it's called the VT for the specific reason. We're going to make a PF4 input, PF3, PF1 outputs. So we're going to initialize the ready to high and the VT to low. So initially it's going to be high. We're going to repeat this sequence of operation over and over. So this is all going to take place in our while loop. These are the instructions that we're going to follow. I've already coded this out, so just for time we're going to go over it. These defines are already given to us. We have our global variables. We need to make this. It's an unsigned long SW. We can call it SW1 because it's for switch 1, but I just have it as SW here. So let's look at our function prototypes. These are also given to us as well. So coming down here, we have our main method, and this is kind of the important part that ties everything together. So this is given to us. It's an activate our grader. We have our port F in it, so we're initializing the PF4, 3, and 1. And this is what our initialization is going to look like. This is also given to us. So this is subroutine to initialize port F pins for input and output. PF4 is input switch 1, and PF3-1 is output LEDs. So this is what it looks like inside of here. We have our clock, allow the clock to stabilize, disabling our analog, and then we have some more about this right here. Remember, when we have ORs, typically we are setting a bit. We have an AND, we'll be clearing that bit. Basically, the OR, for just reference for review, if we have a 0, 0, 0, 0, 0, 0, 0, 0, and then the next line, we have like a 0, 1, 0, 0, and we'll just go for this first part. If we AND these together, well, nothing's going to happen, right? They both have to be 1 for this to work. If it's an OR, though, it'll set it no matter what. Now, if this is a 1, and we pass into 0, it's going to clear it. So and is typically for clearing, and an OR is typically for setting. So that's going to be our port F in it, and that carries over to the rest of our functions as well. Note this is the different colors of our LEDs. We're going to be using red, and we're also going to be using green. So let's go back up here. So in our main function, these aren't given to us. Let's go over them though. So the first one is to ready the signal going high. Well, for going high, we want to set our ventricle right here, the VT. So first it's going to be red. We're going to wait for our switch to be pressed, but that's the next part. The first thing we want to do is set our ready. So we want the ready signal to go high. If we look back at our diagram right here, it looks something like this. So we want to wait for this. It's going to be high. So set ready, the ready signal goes high. This is our ready signal, this first part right here. So our ready signal has to go high. Let's look at what we have here. In our function prototypes, we have our set ready. It's of type void. So let's actually scroll down to our set ready. It's going to be all of these functions we have right here. Scrolling all the way down, we have our set ready. So in this function, we want to set our GPI port F, data R, ORed, since we're setting it. Remember, setting is OR. We have OR, and it's going to be 0x08. Remember, 0x08 is going to be green. So it's actually going to be green first. So it's going to be green first. 0x08. That's what we are setting right here in our set. So that is our set. Let's look at what we have next. So next we have a wait for switch to be press inverted. If we look at our diagram too, helps kind of tell us what's going on. So when the switch is pressed, this is going to go down. So when our switch is pressed, we want for as low. So we're waiting for as low. That's why the as low is right here. So if we go to our as low, it should be right here, void wait for as low. Notice how all of these we also have instructions as well. So for this one, it says the subroutine reads the AS input and waits for a signal to be low. If our AS is already low, it returns right away. If our AS is currently high, it'll wait until it goes low. So we want to run this as long as it is low. We're going to do this in a do while loop. So we initially check this, and then we're going to have this while right here. So this while is going to continuously run this as long as it is high. So if AS is currently high, it'll wait until it goes low, meaning we have to let go of the switch. So it's going to be 0, 1, 0, which is going to look something like this right here. So that's going to set it like that. We can go back up here, and you might be saying, well, that's not a different color, right? That's none of the colors. Let's mention that really quickly. This, before we go back up, this 0x010 or 10 is not any of these colors. Well, what is it? If we look at our diagram right here, we can see that we are clearing this and because we are going from high down to low, wait for as low. So we want it to be this and right here. See, our B is like this. Now let's look at our C. If we scroll back up, our C is going to be the ready signal goes low. So what is this? Ready signal going low. Well, we set the ready, we should be clearing the ready now. So in clearing our ready, which is the C, it's going to go basically down here. We have a 0.8 right here. So when we go to clear ready, which is somewhere in the middle right here, we're going down, we're inverting. So it's going to be an and, since we are clearing. We're clearing, inverting, and it's a 0.8 here. Because of the 0.8 right here. We're shifting the bit to the third over, which is what we have here. Previously, and this is 10, we shifted the bit 4, but now it's 3. Now let's look at what we have next. So next should be D, and D we are going to wait 10 milliseconds. So we have this function delay 1 milliseconds up here. We're passing in 10, because whatever we pass in here, we're basically multiplying it. This delay 1 milliseconds delays it by 1 milliseconds, passing in this 10 times 1 milliseconds gives us that 10, super easy. I grabbed this from our previous lab, the playlist link below the like button, lab 6. This was given to us. This is for 100 milliseconds. I just modified it so it's for 1 milliseconds. We don't need to modify this, it's just for 1 millisecond. Make sure you change the name because they have a different name. 1 millisecond, and this is delay 100 milliseconds. So with that passed in, we're going to delay for our 10 milliseconds. Next, we wait for the switch to be released. Well, when the switch is released, it's going to be E, right? So the switch is going to go high. It's not going to go low, it's going to go high. And when it goes high, we're going to wait for as high. So if we go here, wait for as high. Now it's going high, it's going to our 10 right here, and it's going up. So if we go to wait for as high, we have this information right here. If it's currently low, wait till it goes high. So we're going to run this as long as it's low. So while it's not switch 1, meaning, well, it's not 1. So while this is 0, we run this. And we're going to AND this. It's going to be our 0, 10. It's going up here. It's similar to our A. There's no inverse because our A is solid right here. It only drops with our C. And we covered the C earlier. It's a ready signal go low. When it goes low, it's going to be the inverted part. We're going to delay for 1 milliseconds again, times 250. So we're waiting for 250 milliseconds. Same thing. Now we're going to set the VT, delay, and then clear it. So let's look at our set and clear. This is for G and I. Note how our delay has to deal with this parts right here, the long parts. Now, this F right here and the red next to it represent the green LED and the red LED. So if we scroll down for our set VT and our clear VT, remember, we're going to go down to line 126. We have our set VT. We're just setting this, simply setting this. So setting, we have an OR right here, OR equals 2. We want it to be the 2. So we're setting it to be 2. And then we want to clear it afterwards, right? So it's going to basically, for the G, it's going to go up. So it sets it. When we go down, we go to I. And for I, we go down. Going down, we're going to invert it because it goes down. So that's how our clear would work. And that's how we would write this code. It's pretty simple once we get the hang of it. Hopefully that helps understand everything. From here, we're just going to build it. Make sure that we're using the simulator. We can go into our debug, but make sure you build the project first, build the target, debug. If you have any problems with that, first video in the playlist, link below, like button, help solve that. You can also go to clean targets before you do build and then debug. We have this new window here. How I got it, I went to peripherals, TExaS waveform, and TExaS port F are both selected. The port F is going to be this. It's going to grade our actual project, and our window is going to show basically what happens here. It's going to show an expected output, our output, and then the actual testing input. So if we click grade here, we can watch this go through its process. And we got exactly what we wanted here. So everything looks good, everything checks out, and that's going to be it for the simulation. Now we're going to look at the board. So to do the board, I'm going to come out of the debug right here, make sure the board is on and plugged in. We'll switch to the board view in a second. Go to the build, go to debug, switch from simulator to use the ICDI, click OK. We can build our target, and then we can go back into our debug. Now, the green light on our board should appear. If it doesn't, all we need to do is press the reset button. And we'll check this out in a second. 1 second is up. We are on our board now. So this is our green light because our board is on everything. To start this, we're going to press the reset. We have a green light that comes on. Now what we're going to want to do is press and hold this switch, the first switch right here. So pressing and holding it, it turns off. Now if we release it, it'll flash red really quick, and then it'll go to green. So red and then green. We'll do it one more time. Red and then green when I release it. So that's going to be it for this board.